I'll give it to you guys.
All right, thank you. Thank you, everybody, for joining us. My name is Matt. I lead the platform product management team at Redpanda, and I'm joined by Piyush, my partner in crime in engineering. He and I have been working together for several years now, kind of building out this platform, and we're pretty excited because yesterday we actually launched the GA of Iceberg topics, which is what we're going to talk about today. So let's go ahead and dive into it. And we'll demystify this thing called a Streamhouse as well as we go along. Some of you probably know Redpanda. We're not new. We've been around for about 6 years. We're a pretty big player in the streaming data space. Got hundreds of customers, hundreds of trillions of dollars of revenue, of course. And we're really a complete platform for kind of end-to-end real-time pipelines. So yes, Kafka compatible, drop-in replacement for your Kafka workloads, or maybe using other services, SaaS services and vendors in the space. But we've really broadened out beyond pure sort of drop-in Kafka replacement, in the market to kind of handling a larger swath of real-time data pipelines from a suite of 300 different connectors, talking to operational databases, sensor data, various protocols like MQTT for IoT data, and so forth, or just using the straight up Kafka API, any client you want to use in producing data into our topics. But we can also transform data in situ. We have a WebAssembly based virtual machine that runs inside of our broker for simple single message transforms, way more efficient than anything else. You can also build more complete pipelines in a YAML-based low-code framework, which we call Redpanda Connect. We acquired a really popular open source project called Benthos, you may have heard of, which is where a lot of these connectors come from. So you can build more sophisticated pipelines if you want to join and aggregate topics together, or call out to AI frameworks like Olama, OpenAI, Vertex DB, a whole bunch of things, or land data in your Lakehouse, which is what we're mostly going to talk about today. And now you don't have to use any of that connector suite or capability. You can just do this directly inside the broker, which is the optimization really that we'll talk about and the benefits that you get. But it's an enterprise-grade platform, has full suite of deployment automation tools, Terraform, Ansible, Kubernetes CRDs, a robust CLI, REST API, all the rest of it. Rich observability, enterprise-grade security, yada, 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 the things you'd expect from enterprise software. And we run anywhere, and I'll say that about 5 times. We run anywhere. We can run, we have a free community edition you can download, run on your laptop. I have a customer running Redpanda on a tank. We can run it in your data center. We can run it in the cloud, self-managed, or as a fully managed service. Use your own cloud credits and discounts and networking and VPC and security you've already set up within your cloud account. Or we can do batteries included, compute and storage included in ours, or as a serverless offering, kind of topic as a service. So many, many options. We run anywhere. The second time. Let's see if we get to 5. What's really unique about the platform? Single engine, all workloads. A lot of people have cut corners and offered a smattering of different products in this space to handle and optimize towards a particular type of workload, ultra low latency, ultra high durability, F-sync to disk after every message, or more durability relaxed. You can use some in-memory caching. We have that, right? Write caching to use in-memory acceleration to go faster with less hardware, or you can have more latency relaxed workloads, or maybe a lot of the data lives in object storage. You can tune those knobs. My fresh data is low latency. My older data is colder and it's in object storage, save some money. Working on landing data directly in object storage as well, which is even cheaper. So there's all sorts of knobs that you can tune and say, well, this topic should go into my Lakehouse. This topic should not go into my Lakehouse. And this topic is super mission critical, low latency, 5 millisecond SLA. 99.99% of the time, because I'm a hedge fund, or I'm doing some algorithmic trading with it, right? Or I'm a data provider, data marketplace, or I'm powering in massive multiplayer game, right? And this is actually part of the live gameplay, so it's super critical. So we have customers running this broad mix of operational and analytical Kafka-based workloads, building out more and more of these pipelines directly in this very simple single broker architecture, and now extending that to lakehouses as well. So we run 10 gig per second workloads. We can run, like I said, at all these different deployment options at the edge and bare metal and Kubernetes, wherever you want. And developer first is sort of where we built our brand, is being very developer friendly, having that small footprint, single binary, but also having a really nice CLI, a really nice sort of APIs and automation. WebAssembly, simple UDFs with a few lines of code and SDK. You can just plug that in instead of standing up a whole separate Flink cluster to do very, very basic things. So that and this sort of streamlined architecture that Piyush will talk more about, where we reimagined what it would take to do a very infrastructure efficient, low latency broker built in C++ from the ground up. We use Raft for consensus and replication, but it's all built in. Data balancing, workload balancing is all built in. All the observability is built in. HTTP interface as a proxy, schema registry, everything, right? Auto tuning, single platform. So that streamlined architecture is really kind of where we got our start. These are the different products, different form factors. I kind of touched on this already. Again, the key thing here is every feature runs in every cloud in every form factor. You don't have to have a little matrix and like, okay, where does this run? Can I use this feature with that feature? Can I deploy in this way? It's one platform. We really ship our entire code base to all of our cloud products, including our serverless product. All right, enough of that. What are Iceberg topics? Iceberg topics are what we launched as GA yesterday in AWS, Azure, GCP, both self-managed and bring your own cloud as a beta. And they really kind of unified this notion of a topic and a table into one seamless entity, right? So it allows you to query stream data as Iceberg tables while it is still streaming. That is, the same data, the same topic, the same log is still supporting stream queries through the Kafka API. Consumers doing real-time read after write or doing historical queries using Flink, Kafka streams, the whole Kafka ecosystem against that data, but also analytics engines and SQL databases querying that data as part of a data lakehouse architecture, right? So the topic is the table, right? And we're integrating directly with your REST catalog, which we'll talk more about, through the Iceberg REST protocol securely, and that could be your Snowflake, your Databricks, your BigQuery, your Glue, Nessie, whatever that might be. We'll talk about that. So you have these problems anyway. A lot of the use cases for your real-time data are use cases that involve mixing and matching that data with other forms of data you have in your lakehouse and building analytics off that, right? So you've got to get the data from A to B anyway. So you can build a really boring, really undifferentiated ETL job to copy the data and suck it out of your topic and then insert it into your Iceberg table or your native Snowflake table or whatever it needs to go, right? That really doesn't do anything for your business that's differentiated, and then you have to babysit that pipeline, right? You have to monitor and manage it. If the schema changes, you have to adjust things. It's kind of a nightmare, right? And it can be actually really infrastructure inefficient. We talk to customers that spend a lot of money just on Kafka Connect environments to move this data around. So we want to really lower the cost by, of course, leveraging object storage, reducing the duplication of data as it gets copied around by all these ETL jobs. Just run that and store the data in an infrastructure efficient way, because as we're writing to the stream, we can also write to the table very, very efficiently because we have this single broker architecture. And it's very simple to manage. It's configuration driven, as you'll see, no really expertise required around Kafka Connect, no building a Spark or Flink pipeline. You can focus your engineering teams on higher value work, I would say, than just saying, this stream needs to be part of my lakehouse because I have an analytics use case. So what is a Streamhouse? All right, this is just an idea that we sort of has been germinating in our heads recently. This idea of a data lakehouse where you can sort of point your analytics tools and platforms, and multiple platforms if you're using Iceberg, at an arbitrary data set that's in the data lake without a lot of sort of a priori work to curate that data. You can bring the compute to the data in the cloud and use, turn off the compute when you're not using it. Great, that's worked really well. Why can't we do that for streams? And why can't that be sort of automatic and inherently built in for streams? So a lakehouse that's naturally stream fed, as I like to say. The streams are constantly and always sort of updating these tables in the data lakehouse, and every stream is a table inherently and automatically. It's not the only thing in your lakehouse, but there's this sort of streaming corner of your lakehouse along with all your other data assets that form one catalog or one set of catalogs in one environment, right? Or looking at it from the other point of view, if I'm running my streaming data platform, a system using all Iceberg topics that essentially make all of my streams tables inherently and automatically with no work, right? Why shouldn't it be the same for streams, essentially? So our approach to doing this was, let's pick an architecture that our users love. Let's not cut corners. remember the horse that we rode in on here in terms of that very efficient architecture that's developer friendly, and make sure that people can adopt this easily and use all the features of the platform at the same time. We have customers running difficult workloads. They're doing high frequency transactional, using the Kafka Transactions API, writes into our topics for CDC into compacted topics. Those compacted topics live forever. Those compacted topics are spread across 2 storage tiers seamlessly and transparently to the application, and then they need to land that in their Lakehouse. This is not necessarily an easy problem to handle at gigabyte scale while shuffling a lot of other workloads that are like super low latency workloads that are operational, right? These are hard things, but the thing about hard things is they're hard, and people will buy products and pay you money if you solve hard problems, right? So instead of cutting corners and saying, well, this will work if you don't use 33 features, let's build the right architecture from the ground up and then SaaSify it. So let's sprinkle the SaaS bits on top, and the Streamhouse roof will be added, but it's most important that it has a good foundation. So the principles that we sort of focused in on when we designed this environment are continue to make this one platform that you can deploy anywhere. No ifs, ands, or buts about can it be in Azure or GCP or self-managed or bring your own cloud? Can it use compaction in transactions, right? Can it run in my existing account? In fact, in my existing VPC, we have an ability called bring your own VPC. I've created a VPC in AWS already. I've already got the security set up, the networking set up. I want to just deploy this stuff into that, but I want you to fully manage it. So we can do that. And if you want to do it that way, which means everything runs in your account, truly everything runs in your account. It's not the case that maybe your ACLs or your schemas or some other pieces of critical metadata that are required to keep the environment live, if our entire control plane goes down, are running, let's say in our account. No, they're all running in your account. 100% of anything that's mission critical is running in your VNet, in your VPC, in your Google network. So it's truly sovereign cloud. And it's a single product. So you don't have to migrate your existing stuff. You have existing topics, data, and clusters. Upgrade. This is a feature. It's not an upsell. It's not an additional product. It's not a migration path. You don't have to move anything, right? That's a really important design point for us. And continue to support that broad mix of workloads that I talked about before with those different properties. Okay, make the UX easy to adopt. Minimalist user experience, right? The topic is the table. It's not a connector approach. I don't have to manage them separately. That's the whole point. So we took a very opinionated stance here. If you delete your topic, by default, it deletes your table, right? When you create the topic, as soon as you start producing, it auto-creates the table, registers it in your REST catalog, starts committing transactions to it, provides the schema to the Iceberg catalog. But it builds upon tiered storage, which is a feature that we've had for many years, where your data automatically rolls into lower cost object storage as it ages out of the local storage. And we leverage as much local storage as you have, bring down additional data to sort of make that head of the partition of the Kafka topic be low latency. And you've already configured your bucket, your IAM role, talking to STS for credentials and Kubernetes, very secure. You don't have to do anything else, right? You just flip a switch, toggle it on or off, define the partitioning scheme, define the schema handling approach, how we're going to flatten, schematize, transform your data into a topic. It's all via topic properties, so it's very DevOps friendly. And then self-driving wherever possible, right? We want this to feel like one system. This is an end-to-end workload. We produce into a topic. Maybe we do some simple transforms to prep the data. We land it into Iceberg. That is all one workload. If the Iceberg table starts lagging, we need to back off, right? And we need to manage that. Piyush will talk about that. And continuing to self-balance the workloads and the data and spread the workload with an application-aware, topic-aware balancing, including for the additional work that we're doing to land the data in Iceberg, which is the Iceberg workload. So seamlessly adding this workload to the environment. I mentioned before, we're not cutting any corners here around being DevOps friendly. That means for this capability, the Iceberg topics, it needs to be accessible. Kafka API, REST API in our cloud, Terraform provider, Ansible, RPK, or if you're doing self-managed Kubernetes in your CRDs, you can declare your topics in a CRD. You can put these properties, these ones are going to be in Iceberg, right? And you can sync that to us anytime you want. Focus on what customers want. We worked with over 20 design partners for over a year to refine what is the MVP that we just launched and our backlog of additional requirements. We didn't rush something to market. We've been working on this since early last year. And we considered the alternatives. I mentioned, we've talked about Kafka Connect a bit, Talked to one customer that we're spending over $500,000 a year just to run a many gigabyte per second workload and land it into Iceberg. So just the Kafka Connect cluster itself is a huge resource hog and a huge expense for them to maintain. Fit seamlessly into existing deployments. I already talked about meet them where they want to deploy. But also, if they already have their schemas registered, if they already are using the wire format, for example, with the schema ID magic byte thing. You guys know about the SERDES if you're Kafka users. Or maybe they just have a protobuf schema, but it's not in their registry, but they want to use that schema. They want to use those same topics. Those same topics may serve a mix of different workloads. We want them to be able to plug into that and also plug into their catalog. And actually, we opted not to host our own catalog because that creates kind of a stream silo, right? It's supposed to be a data lake. So we focus really on providing a simple catalog, but pushing metadata into the user's catalog and work with whatever catalog they already have, right? So cast a wide net, support the broadest range of catalogs because this is a fast-moving ecosystem. It has been over the last years, and you can see some of the names there. So we work with all of the Iceberg basically catalogs in the ecosystem through Iceberg REST, and we have customers using all of those. Okay, Streamhouse as a service. Can we do Redpanda on cloud and Iceberg on Iceberg? Yes, we can SaaSify that. Anybody watch Portlandia fans? We can pickle that. No, we can create a SaaS out of that, right? So we can put the gables, the nice stucco facade, the roof on top of this Streamhouse and make it beautiful and do a little bit more to meet the expectations of a SaaS product. But 95% of it is the same platform, right? So we can SaaSify that. And to SaaSify that, we'll do a few extra things on top. We'll make it really easy to configure self-service. This is obvious, but through our SaaS in a DevOps-friendly way. We'll help them understand, how to connect to this thing. Remember, we get their catalog in play now, so they actually have to go kind of through their catalog to connect to our thing, right? To our tables, if they want to use SQL to access the environment and not the Kafka API. We got to have rigorous cloud-native security for accepting their Iceberg catalog credentials, for example. We have to extend monitoring because it needs to feel like a SaaS to their catalog as well. And you have to deal with the network considerations that everything can talk to each other. Again, in these complex network environments, bring your own cloud where you have maybe AWS Private Link or Google Private Service Connect or Azure, whatever it's called, Private Link involved. How do you connect up those endpoints? So you got to have a simple CLI. I can switch clusters easily because we have this thing called profiles in our RPK. It's a lot nicer than those shell scripts you have in Kafka. I can jump between clusters with the profile, and then I can just enable Iceberg and say I have a REST catalog, and here it is, and it's as simple as that, right? These are just config properties. Or I can just use the REST API. I can use the Terraform provider, CRDs, like any of these things. It's all declarative, right? Developer friendly. You don't need to go to a UI. But if you're a UI visitor, how do I connect, right? Where's my catalog? Where's the sort of root of my catalog if I want to go straight to the files and maybe read the Parquet files directly from my data engineering environment, data science environment, or I want to use Spark to go to these tables, but I'm going to go through the catalog because I have a catalog set up, and where's the bucket? These are the other interfaces that you can connect in the in those tabs there. And then cloud native security, you need to have a way to provision secrets, and the secrets need to be stored judiciously and securely in the cloud service vaults. We do all that in all three clouds for you. And so we manage those secrets if you're using our SaaS, and then we push those secrets to your catalog over OIDC using either client ID and secret or token, which is a feature of the REST catalog. We can define which OAuth scope that we are given access to. They're masked in the UI, and we leverage the existing IAM integration that we have to object storage and so forth. So in addition to CLI, REST API, very simple UI to manage your secrets, right? So this is a lot of work. It's boring work, but it needs to be done. To provide something that's enterprise grade. And then, we have shared infrastructure, so we need to monitor the customer's REST catalog as well, make sure that it's healthy. And we also need to make sure that, everything can talk to each other. So your firewalls, outbound ports can talk to the REST catalog, and you have private link or private service connect endpoints within your VPC if you're running inside your own VPC to talk to the catalog. Okay, but a Streamhouse needs a solid foundation. And that's where my engineering counterpart Piyush will come in to tell you a little bit about the underpinnings.
Thank you, Matt. Hey, everyone, excited to be here. My name is Piyush Agrawal. I'm Director of Engineering at Redpanda. As Matt was saying, we work with a lot of customers and design partners to really understand what it is that they're looking for with Redpanda. And the feedback was clear. Redpanda's job is not just to land data in Parquet or Iceberg, but to actually enable the end user business value. And to deliver that end user business value, we added a bunch of features right into our C++ based broker. And why was that important, and how did we go about doing it? That is what my section is about. Taking a step back, right? Redpanda is based on a thread per core architecture. We extract a lot of performance because we are C* based and we are thread per core architecture, which means that we couldn't have used any of the open source Java libraries out there for parsing, protobuf and Avro and for writing Parquet. What do? We doubled down. We wrote futurized C++20 based libraries for parsing protobuf, for parsing Avro, and for writing Parquet so that we can extract the maximum performance from the system. We also solved some tough challenges along the way. Our customers were very clear. We don't want duplicate data to show up in our queries from Iceberg. We don't want any in-progress transaction data or aborted transaction data to show up in our Iceberg queries. Yes, we take care of all of that for you so that you can be relieved that your data is accurate in Iceberg. What we ended up building is basically a single unified system. It's a single cluster that can meet your low latency and analytical needs without any hand-holding. Operational pain is subsided. With Kafka Connect, you have two different systems. With Redpanda, you have a single system which can do it all for you. It's adaptive. We used scheduling groups and adaptive algorithm for prioritization of systems resources across all of these needs. The single unified system mechanics, a single unified system also kind of lends into this, self-adaptive system where any reason that you have Iceberg lag increasing means we can go ahead and back pressure the Kafka so that you as the user are not managing or babysitting the resources, or you don't have to over provision your cluster. The cluster self-adapts to this balance between Iceberg side and the Kafka side. Now let's talk about the specific features which make it really easy for you. One of the key ones that we've added is custom partitioning. The feedback from our customers was loud and clear. They want flexible data management and they want fast, efficient analytics. What does that mean? The key to both of these values is actually that we allow our customers to partition their data and tables in Iceberg. We have added support for custom Iceberg table partitioning. You can specify a partition spec, give it to Redpanda, and that's it. From that point forward, Redpanda takes care of landing this data as per your specification into your Parquet tables as you've specified in the specification. This is something that is not available with our competing products. It's a topic property, which means I can control the specification on a per topic and hence a per table basis as well. We also support ordered multi-source column partitioning, as we'll see in the next table, in the next slide here. We support all of the data transformations from the V2 spec, from the Iceberg V2 spec. This is, our solution is basically modeled after the Spark partition by DDL. As you can see in the example here, you have a 2-column or 2-level partition spec, one primary by the factory ID, and the other, which is by the timestamp, which has been transformed up to the, to the hour. And if you see the layout of the data in your cloud backend, you will actually see that you have the factory ID first, and then you have subdirectories in there where you have the timestamps, and within that timestamp, you would have the actual Parquet files land. I'm going to have to rush this through a little bit. Of course, the data that's coming in, obviously there's a natural lag of the data, Kafka data coming in. There's a lag to sort of translate that data into, right into Parquet. And there's a natural tension between that and the system's resources and the size of the Parquet files that are generated. The size of the Parquet files, as you folks might know, is very key for fast, efficient queries, which means that Redpanda actually can manage this all for you, but you as a user can also have a per topic configuration, which can say, I can tweak that target lag so that I want my Parquet files to be larger, and Redpanda can go ahead and take it for you. We'll take questions outside in the booth if you don't mind. Then we have dead letter queues. I don't want any missing data in my Iceberg tables. Is a loud and clear feedback. Redpanda by default will make sure that any data that we cannot land in your Iceberg tables is landing in a special table called a dead letter table, which is available in your Iceberg. So you, the user, are in charge to make sure that you can reprocess it, fix it, and all of that, right? All of that is, again, built in. The last thing that I would probably mention is that schema registry. If you folks are not familiar, schema registry is the default source of truth for all schemas in Kafka land. And Redpanda uses that schema registry to understand the data and to make sure that all of this data can be returned to your Iceberg tables as well. We support various different formats here. I'll not dig into it. But the key thing that I would like to call out, if you look at the right side of the screen, is that Redpanda was just told what the schema of the data is. It showed up in our Snowflake open catalog here. Every single field's type is visible to Snowflake already, and it is immediately available for you for querying as well. Not just the initial schema, we also provide support for updating of the schemas. I know there were some questions about that, but we can take that at the booth as well. The last bit here that I would mention is, again, as Matt was saying, we support a lot of the catalogs. We work with Snowflake, Open Catalog, Tableau, Databricks, Unity, Nessie, Glue, and we fixed some odds and ends in there to make sure that we can use this in production with Redpanda as of today. And with that, I will turn it over to Matt.
Thank you, everyone. I know we're pretty much out of time right now. There's some links in the deck. You can go to redpanda.com/redpanda, or you can also go to our website and see a 15-minute demo with Open Catalog. Come to our booth and ask us more questions. We're happy to go into details and enjoy Iceberg Topics. It's GA now.
Thank you.
Thank you.